Welcome to Eureka Math. I'm Mr. Shankel. I'm going to help you today with Module 1, Lesson 22. Let's get started. I'm going to do a few different examples for you today to kind of help get things straight. It's a little tough. We're working on some some conversions and unit analysis problems, and all basing off of rates. So let's start with the first question. A Salt March harvest mouse ran a 360 centimeter straight course race in 9 seconds. How fast did it run? Well, when we want to know how fast something is moving, in this case a mouse is running, we want to know how much distance it's traveling in a certain amount of time. So we have that here. We have 360 centimeters traveled over 9 seconds. So we do have a rate here of 360 centimeters in 9 seconds, but I want to know how many centimeters it travels in 1 second. So I'm going to create an equivalent ratio where the number of seconds is equal to 1. In order to do that, I need to find out how does 9 change into the 1. And in this case, we would have to divide by 9. 9 divided by 9 is 1. So if I divide the denominator by 9, I would also have to divide the numerator by 9. And 360 divided by 9 is 40 centimeters. So now I know that the rate that the mouse is moving at is 40 centimeters per second. Okay, I used equivalent ratio ideas to find this. I could also understand that if I take this rate that I began with and I just do what the fraction tells me, it will also give me a rate. 360 centimeters, the fraction bar means divided by 9 seconds. 360 divided by 9 is 40 centimeters per second. So I can use that idea as well. Equivalent ratios, or just do what the fraction tells me to do, will find me the rate. Just a reminder for you students, the number part of this is the unit rate, and the other part here, this unit part, is called the rate unit. Unit rate is the number, rate unit is the units. Okay? Let's try another example. A slow boat to China travels at a constant speed of 17.25 miles per hour for 200 hours. How far was the voyage? Well, we have a rate that was given to us as 17.25 miles in 1 hour. So that's our rate. It tells us exactly how far this boat will travel in 1 hour. But we want to know how far it will go in 200 hours. So we need to somehow get this so we don't have hours in the answer anymore, and it's just miles. So we're going to use something called unit analysis, and that is I'm going to multiply by some conversion rate that will allow me to cancel the hours and leave me with miles. So in order to cancel the hours, they have to be opposite of the fraction bar. So if I have hours in the denominator in my original rate, I can put hours in the numerator and they will cancel. I happen to want to know how far is it going to be after 200 hours. And now I just need to do some multiplication. You can see here that hours divided by hours, that's 1, or they cancel out. And then I would multiply here to get, I believe it's 3,450. 3,450 what? Well, the only thing left is miles. So that's my answer. The voyage will be 3,450 miles. All right, That's using unit analysis. Notice I just set this up with a multiplication of another fraction. In this case, it was a conversion. It could have been a conversion rate. In this case, it was just 200 hours. It allowed me to cancel the number of hours so that I was left with only miles. All right, let's try another one. Let's see. This time we have a world-class marathon runner can finish 26.2 miles in 2 hours. What is the rate of speed for the runner? Well, right now we have 26.2 miles traveled in 2 hours. We want to know how many miles in 1 hour. So I'm going to make an equivalent ratio. I'm going to make it miles compared to hours. And instead of 2 hours in the denominator, I want that to be 1 hour. Similar as the problem before, we can change the 2 into 1 by dividing by 2. So I would also do that in the numerator. And 26.2 divided by 2 is 13.1 miles per hour. I could also remember that I can take this original rate and just do what the fraction says, 26.2 divided by 2, and that will give me my rate in miles per 1 hour, miles per hour. Okay, there's another one. Let's take a look at another. In this one, Franny took a road trip to her grandmother's house. She drove at a constant speed of 60 miles per hour for 2 hours, and then she took a break, and then she finished the trip and drove at a constant rate of 50 miles per hour for another 2 hours. So we have to decide how far has she gone? What is the total distance over those 4 driving hours? Problem is we have 2 different rates. So the first leg of the trip she was moving at a 60 mile per hour rate, 60 miles in 1 hour. But she did that for 2 hours. So I'm going to set it up this way. That allows my hours to cancel. It's going to give me a number of miles. 60 times 2 is 120 miles. So during the first leg of the trip, she drove 120 miles. During the second leg of the trip, she traveled at a different rate. In this case, she went 50 miles per hour. And she also traveled for 2 hours at that rate. So I'll put that on top. That allows me to cancel the hours out. And I get 50 times 2 is 100 miles. Notice in both cases I crossed out hours. I was left with miles. And that's what I wanted. And then to get the total distance of the trip, I would just add these together. And I would know that the total distance of the trip was 320 miles. All right. I'd like to do one more problem for you just to show an example of the type of conversions that we've been doing in class. So let's try one more, and we'll start with a rate of let's say that someone is walking at a rate of 20 feet in 1 second. We'll make it a little easier. We'll start with that. So I'll give you the rate right off the bat. And I really want to know how fast is that in miles per hour? How fast in miles per hour? That's what I really want to know here. Well, in order to do this, we have to make some conversions. And the first thing we'll do is we'll notice that feet is not the number of units that I want here. I want my distance to be measured in miles. So I need to multiply. Oops, let me get a multiply here. I need to multiply by something that allows me to cancel the feet. Well, I know if I put the feet opposite of where they are to begin with, it's in the numerator here, I'm going to write it in the denominator. That allows me to cancel them out. I can change the feet into what I want it to be, miles, because I know that there are 5,280 feet in 1 mile. Okay, and notice that I've canceled the number of feet, and I'm left with miles. That's what I want. So I'm good so far, but there's more work to do. I need to now get rid of seconds. I have seconds right now, but I want it to be hours. So I need to change seconds into hours. The only way that I can get rid of the seconds is to put them on top. If I put seconds on top, that will allow me to cancel the seconds on the bottom with the new rate. And I want my seconds to be hours. So allowing me to, when I cancel my seconds, it allows me to find miles per hour. And that's what I want. Now, what I've added here is another conversion rate. I need to know how many seconds are in an hour. I know there's 60 seconds in a minute, and there's 60 minutes in an hour. So 60 times 60 is 3,600 seconds in 1 hour. And now notice that I have, let me get a different color here. Here we go. This will work. I have a conversion rate right here. That's in miles. That's the number of feet in a number of miles. And I also have a conversion rate here. So I've used two different conversion rates to help me change feet per second into miles per hour. And then the last thing left for me to do is to just multiply. These are fractions. They're all multiplied together. So 20 times 1 times 3,600, that's going to be 72,000 miles. 72,000 miles over 1 times 5,280 times 1, that's 5,280 hours. So I found a way that I can get rid of my units and leave me with exactly what I wanted, miles per hour. It's exactly what I was looking for, and I did that just by manipulating the conversion rates to my desired outcome. I wanted to get rid of the feet, change them into miles. I wanted to get rid of the seconds and change them into hours. So now it's just a division problem. 72,000 miles divided by 5,280 hours is approximately 13.6 miles per hour. And that's how fast that this person was moving with that original rate. 20 feet per second is the same as 13.6 miles per hour. A little fast for a walk, a little fast for a jog for me, but that is how it converts. Okay, unit analysis, it's going to take some time. If I can just convince you to try it, there will be extremely complicated problems that without using unit analysis it's going to be really difficult. So try it out on these easy ones and get the hang of it, and then the hard ones will be a snap. That's lesson 22. Hope that helps. We'll talk to you next time.